Hello, my name is Jordan Connor, and I will be presenting on the first question from our first lab for biomechanics. So various studies using EMG to measure motor recruitment patterns have found that there is a greater level of motor unit recruitment in concentric contraction than in eccentric contraction. It's also been found that in eccentric contraction, there is significantly less motor unit activation than in isometric and concentric contraction. The purpose of this study was to examine muscle activation of wrist flexors and extensors at concentric, eccentric, and isometric contraction, and we hypothesized that peak maximum voluntary contraction would be greatest in concentric contraction for both the wrist flexors and extensors. We had 8 subjects with a mean age of about 25. All were first-year physical therapy students, and the exclusion criteria included anyone with a latex allergy or any skin conditions that would contraindicate the use of surface EMG. So EMG electrodes were placed on the wrist extensors and flexors on the muscle belly, and we first obtained a maximum voluntary contraction against a manual resistance for 3 seconds. To measure isometric contraction, the participant would hold a 10-second isometric hold with a dumbbell, for flexion with the wrist supine parallel to the ground, and for extension with the wrist prone parallel to the ground. For concentric and eccentric contraction, the participant went through a full range of motion through 5 seconds, first starting in flexion, then extension, in order to measure the concentric and eccentric contraction of the flexors and extensors. Our graph showing peak maximum voluntary contraction in volts showed that the maximum MVC was highest for concentric contraction for both the flexors and extensors, and the same was true for the percent maximum voluntary contraction. We found the mean peak EMG values and standard deviation, as well as the percent max voluntary contraction calculated from these peak EMG values. And these standard deviations are shown by the error bars on both graphs. So because concentric contraction showed more muscle activation than the other types of contraction, our hypothesis was accepted. However, we also found that eccentric recruitment was less than isometric contraction in the flexors, which is not consistent with the literature. We believe that some possible sources of error might have been in our lack of experience when using surface electromyography. So as far as clinical relevance, this study and other studies show that concentric contraction generates more motor unit activation to produce the same amount of force. And eccentric contraction generally seems to generate more force with less muscle activation. So both of these facts should be taken into account when it comes to deciding what type of contraction to use for strength exercise for various patients. Thank you.